Hey everybody, it's Dr. J, and today we're talking about salts, specifically salts of weak acids and weak bases. Let's talk chemistry. So basically, today we're going to be talking about salts. All right, so salts can be formed when we're mixing together acid and bases. And when we're talking about salt, it is as it sounds, right? Like sodium chloride, those type of salts. Okay. So let's get started. When a weak acid reacts with a strong base, right, the salts of the weak acid will be formed. So let's look at an example here. Let's say that we have acetic acid, right? This is acetic acid. And then let's say we're reacting it with a strong base and sodium hydroxide. Okay, so this is our reactant side, and I got my acetic acid together, and then in our base, we gotta understand that when it's in solution, it's in these ions form. Okay, so what happens is that the salt, okay, of this weak acid will be formed. Okay, so the weak acid salt is going to look like this: sodium acetate. Okay, so this is the salt of this weak acid here. Now, of course, we got to understand it's in solution, so it's in the ion form, but this is what we're producing. Anytime we have a strong base and a weak acid coming together, the salt of that weak acid will always be formed. Okay. And then, of course, going back to Chem 1, right? Certain things, so as we go through this, you might see some reactions to where, okay, it's mixing. It might look like it's missing something. Well, it's just dropping off the spectator ions, right? The sodium in this case, are just spectators. Okay, just to let everybody know. So when we think about the net ionic equation, right? Basically, that's what's actually producing the salt in this case. We got our acetic acid reacting with our OH from our strong base to produce, right, the salt, or in this case, we're producing that conjugate base. Okay, once again, this is a conjugate base, right, without the hydrogen right here. So once we produce this conjugate base, right, essentially this conjugate base can react with water, right, if we flip them, battery react with water to produce, right, a basic solution, right, going in the backwards, right, double arrow, we still know about equilibrium, all right, that's not going to go away. But we understand, right, the conjugate base can react with water to make that basic solution. Look at a very similar situation, but instead, right, we look at weak bases reacting with strong acids. What are we going to produce, right? Well, in this case, we're going to produce the salt of this weak base, right? So when this happens, when we produce this salt of the weak base, we got to understand that that salt of the weak base is acting as a weak acid, right? In this case, the conjugate acid. So if we look at, once again, another example. Let's say that we have ammonia, NH3, reacting with a strong acid, in this case, hydrochloric acid, right? HCl. And we're going to produce, right, in this case, the salt of that weak base. So in this case, the salt of that weak base is just ammonium chloride, right? NH4 plus and our chlorine. This is our salt. Now we understand that in this case, the salt of this weak base is actually our conjugate acid, right? NH4 plus. So when we look at our net ionic equation down here, NH3 plus our H plus, right? These are the things that are actually going to be making this conjugate acid, right? And we got our NH4 plus, our conjugate acid. So understanding, right, with equilibrium, our conjugate acid will battery react, right? It can react, in this case, with water, like we mentioned with the other example, to make a acidic solution. Okay, so in this case, it's making an acidic solution. It produces a proton. Okay, unlike the other solution where it produces that base. Okay, so these are the things, right, we got to understand, right, just the concept. Let's get the concept down. If we got a weak base reacting with a strong acid, we're going to be making a salt of that weak base. And therefore, if it's a salt of that weak base, we actually have a conjugate acid. And then let me go back one more time. just to remind everybody of this, if we have a weak acid reacting with a strong base, right, we're making the salt of that weak acid. Therefore, the salt of the weak acid is a conjugate base. All right, so it's still the same type of stuff, right? Conjugate base, conjugate acid. Now we're throwing in this salt word, right? Now I have a little, flow chart that is very helpful, to figure this out, right? How can we tell, um, what type of solution we're basically going to get, right? So let's look through this flow chart. Um, so at the very top, we got our salts, right? Once again, salts. We're seeing the cation anion effect, right? So basically, that's what salts are. It has ionic compounds, right? So cations come from the base. We got to understand that. Anions come from the acid. Okay, key thing. Now, if we look at the very first thing, like I said, if you guys get this flow chart down, this is going to be very helpful. Identify the cation. So first off, let's figure out the cation, right? Is the cation from a strong base? So basically, remember the strong bases, right? It's either coming from the group 1A or it's calcium, strontium, or barium, right? Those are the strong bases. If the cation is coming from a strong base, then, right, let's go down here. Then we have to figure out the anion. And if the anion is coming from, in this case, a strong acid, then we're going to have a salt solution that will be neutral, right? So basically, your salt will be coming from a strong acid and a strong base. That's essentially it. That's the only time we're really going to get a neutral solution overall, okay? So it's coming from a strong acid and a strong base. Now, if you have a strong base, but the anion is not coming from a strong acid, right? Then that means that the anion is coming from a weak acid. And if it's coming from a weak acid, then the anion is probably going to be a good conjugate base, right? Because we understand with these neutral solutions, right, they're more on the weaker side of the weaker conjugate base or acid, right? That's the reason why they have this neutral solution. But in this case, that weak acid is actually probably going to produce a good conjugate base. So because it's a good conjugate base, that means that when they go to batch react, right, as I mentioned earlier, that solution that will be made will actually be a basic solution, right? The salt of that weak acid, right? And that's basically because it's a good conjugate base. So it's going to produce a basic solution. Now, if we go back to our flow chart, let's say that, right, our cation isn't coming from a strong base, right? So it's not coming from alkali metals or calcium, strontium, barium, right? It's coming from something else. So if it's not from a strong base, right, then we ask ourselves this. The cation, is it from a weak base? Well, of course, right, if it's not coming from a strong base, then it has to be a weak base. So essentially, if you got a cation coming from a weak base, then your cation is your conjugate acid. Please remember those terms, right? So your cation is coming from your weak base. This is what we do from here. So now that we know we got a weak base, then we need to ask ourselves, okay, is the anion from a strong acid? So if I got a weak base and a strong acid, well, what does that mean, right? Well, that means that my salt solution is going to be acidic, right? Because the salt of the weak base produces acidic solutions. If our cation is coming from not a strong base, but a weak base, and then not only is it not, it's coming from a weak base, but it's not even coming from a strong acid. In this case, we have a weak acid and a weak base. Then what do? Well, we'll say that for later. Okay, we'll say that for later. Okay, so of course, y'all knew I wasn't gonna have to give y'all everything. Y'all gotta check the new upcoming video. But this is a key thing. This is a key thing, right? Focus on these yellow boxes. If it comes from a strong base, strong acid, you're going to have a neutral solution. If it comes from we look at this box here, if it comes from a weak, in this case, weak acid, right? Comes from a weak acid and a strong base, you're going to have a salt of your weak acid. And if it's a salt of your weak acid, you're going to be making that basic solution. And then we look over here. If you don't have, in this case, a strong base, but you have a weak base reacting with a strong acid, right? That salt is coming from the weak base. You're going to be making that acidic solution, okay? So that's what we're going to talk about today. That's it. I highly recommend looking at this flow chart, taking pictures of the previous slide as well.